Okay, all right. So yeah, I was saying LJust is for left justification. Let's just say you have some space before the name and you want to add LJust function. Okay, my keyboard is sometimes bad, it doesn't let me type. 1 second. um, Sometimes I'll have to copy paste. It's not letting me type only. I don't know why. Okay, now it's okay. um, okay. Okay, LJust, what it is doing is, as you can see here from the results, it is adding space to the right. So basically it is moving the name of your uh, string or whatever the string you pass to the left side. That's why it's called L justification. Okay, so it moves the string to left and adds space to the right. I've specified 20, so it is adding 20 spaces. So likewise, if you try rjust, um, it should do the opposite. Okay, it's doing the opposite. Okay, let me print it in our next line, otherwise you lose the results. Okay, now this does the opposite. It moves the string to the right and adds space to the left. Okay, so that is what you see here. So that is LJust and RJust. And then lower is, anyway we saw, lower is just to convert something into lowercase. If you have like this and you just want to convert to lower, you get the lowercase. And likewise you have something like lowercase, but you want to convert to uppercase, you get uppercase. So lower and uppercase. Okay, now so L strip is interesting. Okay, I make use of this day in day out. Okay, so what happens is, in various surveys, right, they ask user to enter their name, their email address, etc., etc. Some users, while typing their name, they will add some space like this. They will enter their names. The same details are captured on the databases also. Now, in order to, even before we start the data analysis, we'll have to handle these scenarios. So what we do is, we simply say, okay, you left strip. L strip is left strip. Wherever you are seeing L, it is left strip. So when you do a left strip, whatever the left spaces were there, they are removed. Now because you have proper name, you can continue with your analysis. Okay, that is the use of L strip. Likewise, if you see, okay, I will add here. So R strip. If for R strip, interestingly, it removes only right side spaces, which you see here. It does not remove the left. And the same thing for L also. I will add some space here. Okay, so L strip will remove left side space, which is removed here. Right, R strip will remove right side spaces. Now there must also be another function that removes spaces completely, right? So that also we have. We it's simply called strip. Okay, strip will, whatever the name you have. Okay, if you type strip, it will remove the spaces completely, both on left side and R side. Okay, left side and right side. So we make use of strip often. Okay, in your analysis um, and all, you will make use of that. Okay, that is about L strip. R strip and strip. Starts with we already saw, and ends with we also saw. Title also we saw, it only makes the first letter uppercase. Upper also we saw, it just converts to upper space. Okay, and now we also have swap case. Okay, um, okay, let me come from here. Make trans returns a translation table used in translations. Now honestly I haven't got much use cases where I have used this make trans. Interestingly, what it does is it's very simple. Um, so let's just say you want to replace some letters. Okay, so you just make trans of. Is it not working? Okay, fine. Help of. One second. Make trans. It will allow you to replace one letter with another letter. That's what it does, but I don't know why it's not letting me type here. I will directly type. Let's see. I'll replace yes with or maybe p with b. Okay, now if I want to print, okay, uh, print this entire thing um, with a translate. Now, let me assign this to some value. Okay, some value I will assign, and I will also print that. So just to make you understand how it is working, here I will print whatever the value was there, Sadiq Pasha. Okay. Whatever the value was there, that I'll replace with um, translate. Translate of what? Okay. Okay. So make trans, basically what it does is make trans. It is trying to get the values for these letters. For P the value is ASCII value is 112. For B it is 98. Okay. So first it is trying to understand what values are for these variables, and on addition to that, making a note of those values, when you apply translate with those captured values, it will, okay, this was not executed, so it will replace accordingly. If you see my name, instead of Pasha now it became Basha, because we replaced P with B in this name. So make trans, it captures the mapping first. Okay, what the ASCII values it captures. For example, if I say instead of sad you type happy, so some joke it will become. um, okay, they should have equal lengths also, by the way. Okay, sad, let's just say wad, whatever. Okay, so if you notice, for each letter it took those values and mapped. So 115 was replaced by 119 ASCII value. 115, by the way, refers to yes in small letter yes, and 97 refers to A, and 97 is replaced by 97, 100 by 113. So this is letter S, A, D replaced by letter W, A, Q. So it captured the mapping. Now when you asked it to translate those mappings and apply it to a string, it will execute. Okay, wahih, something, wherever s was there, it has replaced. Okay, so this way you can make the strings mutable. Otherwise, a string itself is not mutable. Uh, okay, strings by default are immutable, but whatever the mappings you want to capture and translate, once you translate, you get new values with replaced values, whatever uh, the values that you passed. Did you understand this? Make trans. Um,
Yes,
Yes.
Alik.
yes. Okay. All right. Okay. So although I mean, this is not very much used. I'm not come across even a single use case in my whole experience. Um, Partition. Okay. So city dot partition. Now what partition does is it divides the word. Okay. If you pass a separator we already saw in the print statement. Separator will tell you how to separate the words, either with a comma or with a space or with a dash or a star, whatever it is. So partition will use that separator and divide it into various chunks basically. Okay, we will see one second. So if I have not city, because city is entirely one word, let me pass this one only. So let's just say you have Sadiq Pasha and you want to pass the separator. Separator is a space. Now see what happened. It separated Sadiq as one word, that space as another word or another string, and Pasha as another word. Okay, that way. If I had passed A, letter A, now see what happens. Wherever letter A is there, there it will separate. S is separated, A is separated, and this entire thing is separated into one. Although it has not separated the second time, if you notice there is another A, but it has not separated simply because it separates only one time. Okay, so into three different partitions. But now I will say I want five partitions. Okay, it's, hmm, it's not taking that value. Okay, so maybe it divides into only three chunks. That's what I am understanding. So partition, wherever whatever the value you pass, you can pass I whatever, just to give show you the example, I'm just using various other letters, or you can even use AS. Wherever AS is there, it will divide there. Okay, not necessarily one letter, you can also use multiple letters. It will divide there, it will segregate. That is partition. And replace is very interesting. So replace is kind of um, you will use it a lot. Okay, we had saved a paragraph. Sometimes what happens is some people as in not some people, as in sometimes the values that are captured in the files, they will have to be replaced. Okay, so what replace will do is it can replace any word into any word. For example, uh, I have a word single here. I will replace that single word with something else. Old is single. Now new word you have to type. New word is what you want to, let's just say for the sake of simplicity, double. Enter. Now you see you have double. Previously, okay, I will type para again to compare. If you see in the para you had single word, in the replaced one you have double. Okay, replace is used to literally replace whatever the words you have. Okay, so till here please um, type and let me know. So make trans, translate, partition, replace. And para you don't worry, because you don't have to type so much. You just type 4 to 5 words for para. Okay, para equals to you can type from here to here, and then replace the word with colon with something else, or side left with right, something like that. Don't have to follow exactly my examples. Let me know once you're done.
Yeah, Sadiq.
Okay.
Information.
Yeah. Nida.
A minute, I'll let you know.
Sure. Sure.
Yeah, done, sir.
Okay. All right. Next is, see, R find is same as find. Find we saw, right? It returns the index of whatever you find. Okay. So it is also same, and index is also same. Index also does the same work. They have multiple functions for that. R partition is also the same. Instead, R, okay, I can show you. Okay. Let's just say this is partition, and I will add a new cell here for R partition. You see, the results are the same. Okay, there is not much difference. It's just that the partition is starting from the right side. That's all it is. Okay, here the partition starts for left side. Here the partition starts from right side. Okay, one example I can show you is which using which you can understand. If you partition with A, okay, this is R partition, and let's try the other partition without R. Okay, if you see, for normal partition, it goes from left to right, and wherever A is there, it partitions, separates. Okay, that's why you get this. R partition means for the same word, it will go from right to left. So it immediately found the first letter A here. That's why space is 1, A is 1, and rest of the word is 1. So it is going from right to left for R partition. That's the difference. Okay. Okay. All right. So R partition I will remove, and likewise same for R find also, R index also, same thing, but it's just that it goes from right to left. So I'm going to skip those. uh, Again, R split also I'll show you. Okay, para dot R split. Now split is a very important function. Okay, this you are going to learn in natural language processing also. Very important split. Okay, for tokenizing and all. So split means you had this paragraph. It is literally splitting each and every word separately. Okay. So left side. So if you see, all these words are splitted, and R split is also same, but it's just that it goes on splitting from the right side. But ultimately, you will get the same result. For if you split the same sentence, you get this same result, but the split is happening from the right, which we can't see here. Okay, we can't see because the end result looks the same. Okay, splitting process is not shown to us, right? Interpreter does it all by itself. So the end result will be the same, but the logic is first it will split comma, then it will split character, then it will split string, then one single, that way. That is done by R split. Normal split is going from left. First it will split the, then left, then side, then then off, then that way. But the ultimately end result is the same. Okay, so that is split for you. Split lines. Now split lines is very interesting. Let's just say you had one paragraph, okay, and then I will define, okay, above, let me define para 1 also. Para 1 I will define something like, hello there, how are you? Okay, this is my para 1. Now what split lines does is, it divides, if you see, for anything that you pass inside this, okay, for any string that you apply this method to, it will give you a list of the lines in the string. Okay, wherever you want, wherever you see the space, it will break there. But in our case, okay, split lines is better understood when you have a file with lot of sentences. Okay, here I will still try to demonstrate, but let me show. How do I show? um, okay, all right. Okay, let me see, let me get this. Okay, basically split lines will split at the place where you get this space. Okay, now I will still try, let's see. Okay, okay, here you can see. Okay, what it is doing is, split lines, whatever I have specified, okay, for each end of the line, wherever you are getting a new line character or a space, it is adding as a comma and separating that as a sentence. Now this, see, initially the way how I defined is, everything is in triple quotes. That means everything is a single, okay, single comment, single string. That is how I have defined. But split lines is dividing, wherever it encounters a new line, it is dividing that as a separate sentence and adding a comma. Okay, that is the task of split lines. So in a gist, split divides at word level, split lines divides at sentence level. That's the understanding. Okay, okay, did you understand this split lines?
Yes, Sadik.
Okay, now swap case is very simple. City you already had, and now for city, if you add a swap case, it is only going to reverse whatever was in lower case. If it was in lower case, it will become upper case. If not, it will become something um, or reverse. Okay, I will show you this also. I will have q space. Okay, this will be my string dot swap case. So if you print, you see wherever small letters were there, it became capital letters. Wherever capital were there, small, it becomes small letters. That is the work of swap case. And translate we applied already. So in order for you to apply translate, you need a map. This mapping, ASCII mapping, and that is obtained using make trans. So basically, make trans and translate, they work together. Okay, so that we already talked about. And zfill, zfill is, let's just say you want to add additional string to the existing ones. Okay, let me try. Um, let me try this para 2. I will call it para 2. Okay, this is para 2 dot zfill. Okay, um, replace hello with. Okay, all right. So just I'll add. Okay, fine. Added 5. 1 second. Um, okay, so you have a string zfill of let's just say 10 you give. Okay. So I don't know why, but even for small values they are supposed to work, but they are not working. Okay, so you zfill means it is also again kind of appending a mechanism, prefixing mechanism, where whatever the value that you specify to that value will be added so many times. Zeros are added. I don't know if they are 100 times. I can check the length. Okay, len of para 2. Okay, so len of para 2 is only 24. Okay, I'll have to find out why this is only adding 24. The entire length is only 24. Something is off. The length is not 24. No? Acha, acha. Okay, okay. I think I understood why. Okay, I'll have to calculate the length, complete length, right? Not just. Yeah, you got it. So basically, what zfill does is, whatever you have, this string you have, it will try to increase its length by adding certain values. This zeros are added just like that. Okay, random values. So it will add those values and make the entire length to 100, whatever the value you passed. In a way, in a sense, it means to say it is stretching this sentence to make its length as 100. Okay, so that's why when you calculate its length, its length is totally 100, and 100 is the value that we passed. So earlier the value was only 24, length was only 24. We wanted it to be 100 and it became 100. Initially when I tried with 10, it did nothing because its value was already 24. The length is already 24 here. Okay, length is 24 for this, and when you pass a value smaller than 25, 24, it doesn't work. If you pass 25, sorry, if you pass 25, it should add only 1 0. Okay, it has added only 1 0. Okay, so that way did you understand this part? So basically it is stretching that sentence string to make its length based on the value that we pass. If I pass 30, it should add 6 zeros or 6 zeros. Okay, yeah, 6 zeros is added. Okay, so this should conclude. You can start typing now. This should conclude the um, strings and methodologies. And one last thing I will say is we call it string operations. Okay, this also I will complete, then you can type. Okay, just pay attention for 1 minute. It turns out in Python you can add strings. I know, right? So you usually we add numbers, but you can add strings. When you add strings, they get added like this, one after the other. And you can also multiply strings. Okay, so that also a mechanism is there. If I multiply uh, for a multiplication, we use star here 5 times. You see, 5 times it gets multiplied. Okay, so multiplication and addition are supported. Multiplication with a numerical value, addition with a string value. So these are also supported in strings. Okay, this concludes our strings part. Basically, you can make a note of this and let me know once you're done. Or you can I'll upload the workbook. You can take it from there also. Either way it's fine. um, so tomorrow we will be discussing more on lists. Okay, and lists, because if you have understood these strings, no, understanding lists is very easy. Very similar methods apply there, with very similar indexing, very similar slicing. Everything is same there, mostly same. So understanding that is easy. If you understood list, then tuples is only one minor change between tuple and list. Then understanding tuples becomes very very easy. Okay, so both we'll talk about tomorrow. Lists and tuples will learn together tomorrow. Okay, so yeah, any doubts you can ask me now. I'll be happy to answer.
No doubts for me.
No doubts. Okay.
No, sir.
Okay, so is there any changes you want me to do in the way we are teaching and learning? um, so that also is welcome. Any suggestions are also welcome.
Right now, I'm fine with your
Okay,
teaching.
okay, all right then. So if that is the case, we'll do one thing. We will stop it here. Okay.